So this is station 4 on atoms and molecules, and we're going to be using these blocks, these orbs here, to represent the molecules and the atoms that we're going to be discussing today. So the first one we're going to talk about is our example. This is a model of what water looks like. Water is a molecule that's made up of one atom of oxygen, right here you get one O, and 2 atoms of hydrogen. You have a H and you have 2. The formula for the molecule tells you exactly what's inside the molecule. You've got, if you have one, a letter listed and there's no number next to it, then that indicates that there's only one atom of that element in the molecule. If you have a letter listed and there is a number next to it, then that indicates that there is more than one, or however many there are here, in the molecule. So in this case, water has 2 elements. It has oxygen and it has hydrogen, so it's got an H and it's got an O, but it has 3 atoms. It's got 1, 2, 3, because there are 2 hydrogens and 1 oxygen. So to find the number of elements, you add the letters together. To find the number of atoms, you add the numbers together. Don't forget to add a 1 for anything that doesn't have a number next to it. So that's water. Here is ammonia, which is the next one that's listed. It is NH3. So the blue is the N, and then the whites are the H's. Indicated by the formula, there are 3 atoms of hydrogen. So using that information, you should be able to answer the questions that are on the paper. How many different elements? Remember, you're counting the letters. And how many different atoms? Remember, you're counting the numbers. Or you can just look at the model and count them up. There is 1 nitrogen, the blue, and 3 hydrogens, the white. Going on to the next element. This is element number 3. This is ozone. Ozone is made up of 3 oxygen atoms. So there is only 1 element in this compound. There are 3 atoms in this compound. This is sodium chloride. This is element number, or molecule number 4 on your sheet. There is 1 atom of chlorine, which is the green, and 1 atom of sodium, which is the orange. Because there are no numbers listed, you've got 1 of each. So if there is a question that asks how many elements are in here, you're looking for 2. And if the question asks how many atoms are in here, again, you're looking for 2. If there is a lowercase letter next to it, that is the chemical symbol it's associated with that letter. So if you just had an N, like we did over here in ammonia, it would be nitrogen. To differentiate sodium from nitrogen, they put a little A next to it. Over here, this Cl, this is chlorine. If it were just a C, it would be carbon, which is in the next element that we're going to talk about. All right, so this should be enough information to answer the front. Now we go on to the back. This is glucose. It's asking you how many elements are in here. Remember, you add up the letters. You got a C, an H, and an O. To find out how many atoms are in this molecule, you add up the numbers. In this case, all of them have more than 1, so they all have numbers associated with them. And then we get to ethanol. Ethanol is a type of alcohol. Here is the way that the formula is spelled out. I know on your paper, it gives you the actual chemical tree. It gives you everything linked together, kind of like these are linked together. All right, but here's the chemical formula for ethanol. You need to figure out how many elements and how many atoms are in there. You also need to write out the chemical formula, which I just gave you, and I didn't realize that until I just looked at the sheet, but there you go. I just gave you 1 answer. All right? That should be enough information to answer and complete Station 4. All right, 8th graders, so this is Station 5 of your physical science packet. These are 2 of my students. This is Jacqueline. Say hi. Hi. And Ben. Hi. And they're going to be conducting the experiment on your behalf because I can't put M&Ms in everyone's classroom. So for this experiment, what they are going to do is they're each going to open up the package of M&Ms, so do that now. And they're going to take out an M&M. They are going to be Go ahead and eat that one, and then you'll get another one. They're going to be putting them in their mouth as soon as I start the timer. Which, how am I going to do this? I wanted to be able to see it on the camera, but I don't know if I'm going to be able to. Nope, the light's not going to cooperate. Oh, there it is. All right, I'll do it there. All right. Whenever they finish with each M&M, they're going to raise their hand, and then we're going to write their time down on their cards. At the end of it, we will hold up the cards, and we will see where we're at. All right, so in 3, 2, 1, go. Don't you? Okay, Ben is at 1.27, so write down 1.27 for trial 1. Who was that, Tyler?
A teacher wants to send a student over to do a packet.
Did you say okay?
Uh-huh.
Okay. Yeah. All right, are you close? Okay, so 1.45 for you. So I'm going to stop and clear. All right. Okay, that 1.5 is fine. And then on yours, 1.27. All right, everyone take a second M&M. And we'll see if we can get the same results. All right. So in 3, 2, 1, go. Okay, Ben is 1 minute 24. Go ahead and write that down. And Jacqueline is 1 minute 29. All right, and then let me click stop, clear, and we'll go do the last one. So take one more M&M. Whenever we're done with this, the packet is yours. You can take it back and do whatever you want to do with it. All right, in 3, 2, 1, begin. Ben's good at 1 minute 23. And Jacqueline's good at 1 minute 27. Okay, so can you each hold up your cards so the camera can see them? All right, so those are their numbers. They look exactly like the data charts that are on your paper. I'm going to leave it on here for just a second while you guys write these down. You need to be the ones, the 8th graders watching this, you need to be the ones to find the best value. Remember, you add up all the numbers and you divide by the number of trials. So in this case, you're going to add all 3 of Jacqueline's numbers together, divide by 3 because there's 3 trials, and that's your best value. For Ben, you're going to add all of Ben's numbers together. You're going to divide by 3, and that's your best value. All right? Question number 1 at the bottom and number 2 at the bottom. You need to analyze this experiment and determine whether it was replication or repetition, and then you need to come up with your own examples of what replication would look like in a scientific experiment and what repetition would look like in a scientific experiment. Thank you, guys. This has been running for 23 minutes now. There's a heating pad on this side that's been warming up the bottom right-hand side of the camera, the bottom right-hand side of the fish tank, and there's a container of ice that's been cooling down the top left of the fish tank. So I'm going to inject red food coloring into this side, and I'm going to inject blue food coloring into the other side. And hopefully, if this works right, we should see currents flowing through. If this works, then the red food coloring should rise and move from the right to the left. So we should see it rise up and start to flow that way. And as it gets to the ice, it's going to cool down and drop. The blue should flow across the bottom of the fish tank, but once it gets to the red, to the heating pad, it should rise up. So we should start to see a vortex. So the blue sank straight to the bottom and is moving from left to right. You can see.
Why just 24 minutes?
Because I started it 24 minutes ago without the food coloring because I wanted the water to start mixing. And then the red, you can see it's starting to move from right to left, sort of in the middle. For some reason, every time I do this, I don't get complete mixture, but I'm getting a current, a convection current of warm water rising and cold water sinking. The warm water is going to go above the blue, so you're going to see the red go on top of the blue, and then it's going to start in a circular mixture. For some reason, the blue is flowing and pushing the red out of the way. I don't know if the red food coloring is a different density than blue food coloring.
Yes, it is possible because we made from different.
But it's moving faster over here now. Like this part up here is rising faster and moving over faster. So you can see the red swirls.
Yes,
Once it gets over there, it starts moving slower. And it's been running for 34 minutes.
Particles of warm water move faster. Particles
Well, they spread apart and they get less dense, so they rise. When they cool off, they slow down and they get closer together, so they become more dense and sink. So this is low density and that's high density, and that's why this is moving the way it is.
But you see, when you put here blue, there is anything here, but here there is red.
Yeah. Because the blue is pretty much sticking down at the bottom, except for the little bit that's mixed in and is flowing with the current. I'm going to stop it. It's been 35 minutes and it seems to be nicely mixed.
What time is it? Oh, 55.
This has been running for 12 minutes. A thermometer, when you put it inside of a liquid, there's alcohol in the end of the thermometer. The thermometer expands if it's placed in warm water, and it contracts, the alcohol does, if it's in cold water. When it contracts, it comes closer together in the end, and so the excess alcohol is sucked back in and the temperature goes lower. When it expands in a warm liquid, the alcohol takes up more room, pushes up on the line here, and some of the alcohol goes up the meter. And so you wind up with a higher temperature reading. So it's all about thermal energy flowing either into or out of the end of the thermometer as the thermometer sits in the liquid. So in this case, the thermometer is increasing in temperature because the water is a little bit warmer than the inside of the thermometer.